Today I'm going to talk about LeetCode question number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. So for example, in this one, we have BABAD, and obviously the longest substring, a palindromic substring is of length 3, BAB. ABA could also work, same difference. So that's the answer there. And for the second example, CBBD, the longest substring here would be BB, or palindromic substring would be BB, length 2, so that would be the answer. So how would we go about this? Well, if we have, BABAD. So basically what we could do is try to look for all the palindromes that exist in here and find the longest one. Okay, so starting from B, with B as this first character of this new palindrome, find the palindromes, okay? So starting from B, we can look at BA, okay, not a palindrome. BAB, it is a palindrome, so our answer here would be BAB, because right now originally our answer would have been an empty string here, but now we found the palindrome of length 3, so now it would be BAB. Okay, and then continue until the end. BABA, not a palindrome. BABAD, not a palindrome. Okay, so let me write the answer. Okay, so what about all the palindromes starting from A? Okay, so A itself is a palindrome. Okay, I forgot to mention here when we start with B, B itself is a palindrome. Any character of length 1 is a palindrome of itself. Okay, so A is a palindrome, but it's smaller than our current found palindrome here of length 3. This is length 1, so we still keep BAB as our answer. Okay, then I look onward. AB, not a palindrome. ABA, it is a palindrome. It's of equal length to this one, so I'll just keep this string here. Our original answer here. ABABD, not a palindrome. Okay, and so on. That's how we would try to find longest palindromic substring there. So basically, the runtime of this would be running through this string. It'd be a nested loop. So start from here, go through all of these, the rest of the characters, then start from here, go to all these, the rest of the characters, etc. So that'd be O of n squared. And also, in order to check if a given substring is a palindrome, we would have to run it through a helper function like a is palindrome function. And that would cost an extra O of n. So instead of O of n squared, this becomes O of n cubed. Okay? And we can actually do better than that. So how can we do better than that? Well, instead of having each character, start off as the beginning letter of our potential palindrome here, why not have it be the middle of our palindrome, and then we expand outwards in either directions to look for palindromes, to look for bigger and bigger palindromes. Okay, so how does this work? I'll show you a different example here. So if we have A, okay, okay. What if we went through our regular original way? So if we have this 8 here, we would go expand that way, this 8 here, expand that way, etc. But notice how while we're computing these palindromes here, we're always recalculating these same palindromes in our, is palindrome function, or we're always rechecking if these are palindromes that we just checked is still a valid palindrome. If we found that these 3 A's are a palindrome, and we expand our search area to these 4 A's, we check if these 3 A's are palindromes again, along with this 4th A. Okay, so that's kind of a lot of duplicated work there. But if we start from here, say, and go outwards, okay, then we check this once. Is this a palindrome? Yes or no? Yes. Okay, we update our answer if need be, and then we continue going outwards again. And this time when we go outwards, we don't need to compute if the whole string is a palindrome. We only need to compute if these 2 letters are the same. Okay? So if we start from here, we move outwards. Is this the same as this? Yes. So we continue outwards. Is this the same as this? Yes. And we keep going outwards until 2 letters differ, or we're out of bounds. Okay. And this way, we're using a previously computed palindrome to check newer future palindromes. Okay. And this time complexity would be O of n squared. Okay, because we don't need to do that check is palindrome all over again. Okay. So yeah, that's how we're going to do it. One thing I forgot to mention is in these examples, I checked out the palindromes that are of odd length. For example, BAB, length 3, odd. What about palindromes that are even length, like this? So if you do from the middle out, it won't exactly work. But this is a valid palindrome. So what do we do in this case? Well, instead of considering this one character as being the middle of the palindrome, we consider itself and one ahead as the middle of the palindrome. Okay, and here we check, are these the same? Yep. So we continue outwards, and so on. And the same logic as we do with the odd palindrome here, and this will be O of n squared runtime still. So now to code this up, what I'm going to do first is define my longest variable, which is right now going to be an empty string. Okay, so now what I'm going to do is iterate through s, so for I in range s, and each letter at this index I, we're going to consider it to be the middle of our potential palindrome. Okay, for both cases, even and odd. So odd case, this at index I will be the only middle in a palindrome that's of odd length, and with even, this index I plus 1 will be considered the middle elements, middle characters in the even length palindrome. Okay, so for I in range S, so what I'm going to do is take care of the odd case first. So left is going to be I, and right is going to be I. And while left is greater than or equal to 0, and right is less than length of S. We want to make sure left and right are within bounds of S here. And S left is equal to S right. So while the left and right are in bounds, and S left is equal to S right, meaning it's still a valid palindrome, what I'm going to do is, since this is a valid palindrome, I'm going to now expand left towards the left and right towards the right. So left minus equals 1 and right plus equals 1. Okay, and eventually we'll break out of this loop when we're either out of bounds or it becomes an invalid palindrome, meaning these two do not become equal. So what we want to do now in this case is do left plus equals 1 and right plus equals or minus equals 1. And why do we do this? Well, remember, the reason we're breaking out of this while loop here is when we're out of bounds or it becomes an invalid palindrome. So we want to get back to the state. We want the left and right value to get back to the indexes where it was still a valid palindrome. Okay? And then what I'm going to do now is if the length of my longest is less than right minus left plus 1. So this would be our palindrome length. What I'm going to do is the longest is going to be equal to s from left all the way to right plus 1. So we're going to be splitting the string here. Why do I do this operation instead of like inputting this up here? So why didn't I do this with, obviously length like that? Well, because splitting the string takes O of n time, and I want to save time here, so I'm just gonna only splice the string when I have to. So then longest is gonna be that. Okay. And what about the even case? So left is gonna be I, right is gonna be I plus 1. Okay, and basically this is all the same. Yeah, that's all the same there. Okay, and after that, after we iterate through each element, each character in S, where each character could potentially be the middle of our palindrome, we're gonna turn longest. Okay, and the runtime of this is O of n. Let's just rearrange. Oh, sorry, the runtime is O of n squared, not O of n. It's O of n squared because imagine if I have this, and this is our palindrome would expand to here and here, and for here palindrome would expand to here and here, so potentially the palindrome would expand to all the characters. So it's O of n squared. Okay. And now I'll take this for a test run. Unexpected that. Oops. Okay. That looks good. Okay, and I'll submit. Okay, great. Thanks for watching.